Hello, my name is Ritik Datta. I'm a graduate student at the ASU Peace Lab. Today I'm going to talk about my project in this video. The project title is New Methodologies for Predicting Remaining Life of Second Life Lithium-Ion Batteries. The project is sponsored by the HiRare and the project lead is Dr. Ayan Malik, and I'm working under his supervision on this project. For the estimation, our team will explore four methods, which are Coulomb counting method, internal resistance method, Kalman filter based method, and increment capacity analysis method. At first, we have started with the Coulomb counting method, and then we'll move to the internal resistance method, and then later we'll also try to estimate the SOH of the battery through the Kalman filter based method. To estimate the state of health of the lithium-ion batteries using the Coulomb counting method, we need to charge and discharge the batteries quite a few times. For charging or discharging, we are using mega cell charger in this project, where we can simultaneously charge 16 batteries at once using these 16 slots. So we can gather the data from the machine, and then we try to analyze those data and get the SOH of the batteries from there. Can be seen from this slide. We can see that for different charging rates, the voltage of the cell, it differs a lot. So there is also a constant voltage charging here. So we can see for 2.5C charging at around 57% of SOC, the cell starts constant voltage charging, while for lower charging rates it starts later. And also for discharging, we can see the discharging rate also differs here, and for different discharging rates the voltage also differs likewise. Here we can see from the mega cell analyzer we can get the charging data. So after charging, each battery will have a specific amount of voltage, so we can get the voltage, and from that voltage we can estimate the SOH of the battery. Similarly, we can get the discharging data from the mega cell analyzer. After discharging, after fully depletion of the battery, how much voltage will be there. So we can see for different batteries the voltage limit is different. So from there also we can get an estimation of the state of the health of that battery. Here, a previous work is shown to give an idea how the charging and discharging rate it depends on the SOH of the battery. So as we can see, with 800 cycles of charging and discharging, the SOH also decreased a lot. So we can also estimate the SOH from the charging and discharging rates. The second estimation method, which is the internal resistance estimation method, is shown here. For continuous using, the internal resistance also changes, it increases with the time, and it also depends on the SOH of the system. So if we can model the battery and estimate the internal resistance of the battery, then we can also estimate the SOH of the battery. So this is a previous work where they have shown how the SOH of the battery is related to the internal resistance or different capacitance values. So we are also planning to do somewhat like this with a better accuracy. The next steps of our work is shown here. So we'll prepare the voltage, current, and the SOC graph for charging and discharging, and then we'll be able to get the SOH from those curves. And for the internal resistance method, we will construct the algorithm and model the battery, and then we'll be able to get the SOC estimation from there as well. And then we'll compare these two estimation methods, and we'll find which method is more accurate in estimating the SOH of the battery. So thank you very much for staying with me and listening me. If you have any doubts or questions, you can reach out to me. My email address is provided in my page. So thank you.